streaming. Alright, what should I make? Whoops. I don't even know what to make. I'm just bored and I have CAD. So, I'm thinking... To be honest, I got no clue what I'm thinking. So here's the side profile. So coming up, I have the, robotics, kickoff. That's what it is. First robotics kickoff. So what that basically is we start designing our robots with a theme in mind. So I guess I will make a master sketch of... Ooh, maybe I should do... Here, let me edit the stream. How do I do this? Docs. Alright, whatever. Just give me a sec. Like, I hate how it always puts me on a certain video instead of just like the normal. Like, it should just take me either here or to home. But live. Oh, he's right there. I wonder what my stream delay is. I need to fix that. Get it back to a normal time. Where is it? How do I just edit? There we go. Edit. There we go. Robotics kick off practice. Okay. Did I save it? Yep, there we go. So I guess I should look at first robotics. Give me a year. I'll say 2023. Game manual. Alright, here we go. I've already looked at this one before. It's fine. It's charged up. Yep, here it is. So, here's the rundown for it. So, these are platforms where they move back and forth. Here's where you grab the, is that where you place the cones? Yeah, that's where you place the cones. Are those just... Oh. Okay. I guess there's just presets, and then what you have to do, if you're on blue team, you go whoop, all the way over there, grab them, and come back. You really don't... There's going to be a bunch of traffic right there. Maybe you could go right there. I wonder what the height of that is, though. It's probably a decent height. Okay. So, let's say I'm on blue team. Charge the platform there. We'll go there. I need to be able to place cones how high into the air? I need to be able to place cones and stuff up to 4 feet in the air. Is that what it is? Yeah. Okay. Oh, here we are. Okay. I need to be able to place a cone 3 foot 10 inches plus however tall a cone dimension actually is. 3 foot 10. I need to remember that. Okay, 3 foot 10 plus, so 4 foot. Like 4 foot. I'll just say 5 foot. I need to be able to pick something up by down there instead of 5 feet. Okay. So it has to be able to go up 5 feet. What are the constraints for the actual robot? Like that. Okay, so this cube, this is basically just a circle. If I'm gonna be so real with you, because it's just a balloon. You can squeeze it and stuff. I'm gonna just pretend this is a circle, because I could probably suck it up like a circle and do stuff like that. Okay. Yeah, 5 feet. Let me see what the point system is. Two. 1. Yeah, I don't know, like, okay, here it is. Completely left. Okay, if it moves on its own, there's 3. If it scores on a bottom row, then it's during the self-moving thing, then it's 3, 4, 5, 6. Each robot docked and not engaged. Huh? Okay, I'm a little confused by that, but whatever. I'll figure all that out. Okay. I'm gonna be using ChatGPT too. Okay. Control C, Control V. That's some great typing right there. Height 4'6". Okay. Frame 120. Okay, yeah, it's in inches. Wait, 120 inches? Oh, that's for the whole perimeter. Perimeter is just times 4, so 120 divided by 30, 30, 15. We'll just cancel that and make it 15 inches. Which is still a lot, to be honest with you. 15 inches. 15 inches. Now, max height is, what was it again? 4'6". And then mechanisms can't go up. Okay, they can go up 2 feet. I'm thinking an elevator. But I know designs back in this time, there were box-shaped designs that worked really well. I wonder if that could be in play here again. Kind of bullying the way, so back over, where is it? It's right around the bank. Right around, so huge traffic jams up at top. Huge up at top. Especially at the start when you're getting these. I guess you could just kind of go over those charge stub zones whenever you want. I bet you could get some speed doing, whatever. It's not like that speed will really matter that much. Okay. Let me just think of a design. So it has to be an elevator. I think it's like 2 by 1 inches normal stock for that. Okay. I'm machining. I am not a CAD person in any way whatsoever. So me even doing this is kind of a little strange. But how high is it? I think it's around like 4 inches, something like that. So I'm just assuming 4 inches. Because I haven't actually had it. Whoa, that's a lot. Maybe it's 2 inches. Okay, if that's the whole robot, then yeah, it's probably like 2 inches. Okay, so there's the bumper. Of course, the edges are filleted or whatever. We have tires. This will have to get raised up. That sucks. Okay, I might as well just delete this. Tires, I'll just give myself an inch of that. 15, is that what I said? Nope, 30. I hate how that thing gets in the way. 2, 15. Okay, that's just my estimate for the entire sticker outer amount. I'll just kind of, I can just do an arc. No, I can't. Okay. I don't want to do that. Okay, there we go. Yeah, so I was talking about an elevator earlier. I'll probably go back to that design. That seems like a solid plan with the elevator. Except that's so, like, normal. I want to do something cool. Like, I don't know, something cool. What's one way to change height? You could make a muscle type thing, except that would be pretty confusing. Like a boom arm? No, a boom arm. Oh my gosh. What am I talking about? It's right around here, huh? Yeah. Honestly, getting cones are the biggest thing here. There's way more spots for cones than there are any other thing. But if you can get circles, or spheres, balls, if you can get the balls, 1, 2, 3, 4, 5, there's also a lot of ball spots. But you can also just put cones there. So picking up cones would be better. Balls, you don't really have to care about. There's a wall behind that, by the way. So you can kind of just chuck it up there. The boom arm, which is what I'm thinking about right now, is it kind of just, I don't know how to describe this. Jaw. There. So what I'm thinking is, can I change the settings on this? Yes, there we are. So what I'm thinking is, here is an arm. Here is an arm. And it has this other bit to it. There's the arm. And then it flicks up that away. So it would go from this to that, which would stick out higher. Oh, can I move over? Thank you. Goodbye. Stick out basically like just one straight on. Well, that's kind of like, yeah, just one giant arm out, and it's holding the thing here, and then it's holding the thing here. But that thing would fall down to there, so it wouldn't be up there. And then it would just go, let go, and then the ball would drop to wherever it needs to be. This would also work for a cone. You could basically just have some kind of like, ooh, you could technically have a type of bearing mechanism for right there. Something like that. Something where it can flick up and flick down. I have no clue how that works. I'm a first year. I am special. This would work, and you could do it with hydraulic there. You could just go, pff. No, it wouldn't work because it'll extend out. A motor there, like, and then it's over there. That would work. And to make sure you don't have to put a motor up here, you could just have it dead hang basically, but you have to have a way to drop it. You could have a type of can you do wireless stuff in FRC? If so, hopefully wireless. If not, it'll just wire up a controller, bang, drop. Okay. Time to, where's CAD? There it is. Time to design that. So that's including the bump. Okay. 20. Alright, 90 divided by what? Whatever, I'll just do 20 and 20. Everyone's happy. I don't crash. Okay. Another line. 20. 20. Parallel lines. 20. 20. Over this way. There we go. 20. Tab 20. Over there. Constraint by making parallel. Fine, I'll get rid of you and you and you and you and you and you. Parallel. Parallel. I want to hide dimensions because they get in the way. Then I have whatever I have to hold the thing. What's my height from? Ten plus 6. No, oh no, I need that. 16 plus 6, 24. Oh, that's pretty short, to be honest. But this will have a motor flick it over. No, I need to change this angle. That's the issue. Well, that sucks. I just made this thing. Goodbye. Have fun. Bye-bye. Bye. Bye. That wasn't the thing that was wrong. It was just the angle. I gave it a bad angle. I'll say 35, maybe? I guess I'm doing that. Okay, I hate how it auto does that. I mean, well, I guess it doesn't really matter as long as it's getting constrained. 20 tab 35. Tab 35. Tab 35. Tab over there. Yes, good. Circle 6. Okay, now what's the height? Oh my. Ooh. Okay, let's see what the height is. +5 +6. So it's like 30 inches. 30. Okay, we're getting on height for that. Fully extended. That'll be what? Same height? You need to be able to fold up more. This is basically an arm. This is really complicated. Motor. So it has what? 1 degree, 2 degrees, 3 degrees of motion. Nah, I don't have to do that. Really only 2 degrees of motion. I need to make the arms longer though. And not lock them in like place, I guess. Does that make sense? I have to be able to move them. Okay, okay, here's the base. The degrees does not matter. Okay, no, bang. So I have a motor. Degrees do not matter. Okay. Now what happens if I rotate this? Okay. Okay, I have no clue what I'm doing. So if I had a chat right now, I would be begging them for help. Too bad I'm lonely. Guys, I've done this before. I just don't remember how. I think it's this tangent. Whoa, go back to how you were. How did I make that? Okay, I have to check now. Oh, I don't know if I can show all that on stream. Never mind. Oh, no, okay, there we go. I know how. Okay, I keep that point constrained, but I don't constrain anything. Oh no, I have some sort of special rectangle. To 16. Sure, that's fine. Oh. No, it's a different type of rectangle. It's you. Yes. It's this type of rectangle. And I bring you. Oh, whoa, whoa. Okay, yeah, I needed to mention it. 20. Oh, no. Oh. 2. Find dimensions on. Nope, dimensions on. And goodbye dimensions. Okay, now what I can do is I can put this corner onto somewhere. What constraint was it? Might have had to do like a circle, and then taken this corner, dragged it to lock it like that. I need to constrain some of this stuff. Okay, show dimensions, blah blah blah, yeah. Wait, so 1, 2, 3. 1, 2. Oh, that's cool. Of course, it's just barely off. That's wonderful. Get instruction line, good. That's the font. Okay, now this thing is just moving. I think it's all constrained, but okay. That. It's still 1, but how? Ugh. Okay, this is actually really painful. Like, I did not think it would be this painful, but it is definitely this painful. Well, there's the base, fully constrained. Yay! Woohoo! Who's excited and happy that I constrained the base, the easy thing? Woohoo! Yeah, I need a power nap now. Alright, now, so it'll have a motor here that will rotate it back up here. Let me go back to my sketchy thingy. Oh, whoa, okay, can I restart? Is there a restart button? There we go. Dang it. There. There. Okay. Okay. So, we have the motor right there. That goes boop. Boop. Another motor. Boop. I don't want to say another motor, but maybe. And then a picker-upper thingy, which is boop, 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 which actually is 2 motors. So, and this thing, degrees of motion are a pain in the ass. So what I think will actually, I love degrees of motion though. They're pretty cool. I really like them. It's really just coding. That's the really difficult part. Otherwise, this would be really cool. So it has the picker-upper things. Okay, this is easy. This is so easy. I figured it out. No, I didn't. Okay, coincidence, quinkadink. Oop, I need a point. P. Nope. Point. Do you see point? Point. Coincidence. Huh. I guess I have to constrain this point now. Oh, that's over constraining? Okay. Then. Okay, yeah, there should be enough. Coincidence to there. Okay. There we go. Now this thing can rotate, but it can't, yeah, we're good. So, first day of school today, that was pretty light. It wasn't too bad. There we go. Oh, I have to dimension the other way. Oh, shoot. Oh no, it shouldn't be. I could buy a rectangle. You served your purpose. No, you didn't. You were useless. It's because I accidentally put it on this plane when I shouldn't have done that. Now what I have to do is the same thing all over again. I mean, it's not hard, so. Oh yeah. Now this circle will have a 2-inch line on it. I think. You know, I don't really know. 2-inch, but it can't go inside. That's what she said. This part doesn't really matter. I might as well just make it a right tray. Never mind. I'll make it a 45. 2 maybe. 45 degrees, that's what I meant. I got no clue. Okay, is this properly constrained to it? I guess it's fully constrained. Yeah, it is. Okay. And then I need to connect these lines. Collinear. Well, I mean, it worked. It's not what I wanted though. Doodle-doodle-doo, doodle-doodle-doo, doodle-doodle-doo. Wait, if this is 2 and that's 2, then coincidence. Oh, and then I can bend it that. Oh, well, it worked. It definitely did what I wanted it to do. So it didn't work. Wait, does it work like this? Oh, there we go. So it'll go down. Stop. Have another thing, have another thing, have another thing. Okay. This is pretty trash, but I really didn't like doing this. This was not fun for me. Because I like machining. Oh, this is pretty hard. For what it is. Way too hard for what it is. Because I probably did it all wrong. And it's inefficient and dumb and blah blah blah. And we'd never use this many axes. We'd probably just use like, I don't know, something lame. Alright, goodbye. I'm done. Yep, goodbye.